Hi everybody, and so sorry for being late. I was trying to figure out how to find here. Today we're gonna speak about the CCIP read, or the other name is the EIP-3668. And first I will start with myself. I'm Muhammed Tarikulu. I'm a core developer in ENS, or full stack developer, doing pretty much everything. So helping the protocol and also infrastructure and sometimes DAO tooling, basically whatever needed. And of course, as a member of ENS, I have my own favorite ENS names. The first and mostly I use this Tarikulu.eth, and the other one is just my name, Muhammed. And here you see our design of cards. I don't know if you ever been in any event that we were producing these cards. If you have it, so you know. If you don't, I can quickly explain what it does. Basically, it's also kind of your physical identity. So if you will be in any other event that we produce these cards, you can get it from our booth. This card is an NFC card, keeping all the information about you, the which information that you put under your ENS, like your avatar, your profile information, email address. Everything is just in here. So when someone tap with their phone, you can share just like a business card, and also you can issue POP for them with in a way that you meet with the person, so you can verify with that. So the topic today is first, what is ENS, for who doesn't know, and then we will talk about what is CCIP read and what the CCIP read does, and after the key components of the CCIP read and the use cases. So let's start with the ENS. Who is not familiar with ENS? Okay, everybody knows. I'm super happy. And who has ENS? Okay, we should work on that a little bit more. And so the ENS basically started as an idea of how we can fix the UX problem of the blockchain. Because, as you know, when you create a wallet, you just have something nonsense, like alphanumeric characters. They are really long, they are really hard to remember, hard to use, and hard to share, pretty much hard for everything. And the first idea of ENS, when it's founded or created, was basically replacing those alphanumeric characters with easily memorable names or handles. So you could just create or register your handle or domain and then use that domain as your wallet address. So you don't have to go back and, again and again, basically to check, if you are using the correct address, if you are sending your assets securely, or when you want to share or when you want to send some assets to the people, if they are providing you the correct address, if you are, I don't know, just doing some mistake or typo. So this was the idea, basically, to prevent all of these problems. But then we realized that creating this protocol is actually super powerful. Because if we are able to name for things, and if it's not only the wallet addresses, the use cases are just expanding and expanding. Then the first realization was, okay, yeah, we are keeping the wallet address of the users, but why we are not keeping more about the users? Because it's your domain, so you are able to just add any key and any value under that, which is, as I mentioned previously, it's your profile. So you can have your email address there. And you don't have to always remember about your email addresses. You can just give your ENS name, and then under this ENS name, people can see your information. about your email address, or your Telegram handle, or your GitHub handle. And even though, you know, like I'm maybe more than 10 years of developer, sometimes when people asking me about my handles, I'm like, what was that? What was, like, was it underscore? Was it that? And this kind of things. But with my ENS name, I'm just telling that everything is in here. Please just stop and done. So this was the second use case. So we expanded ENS protocol in a way that we can keep any key and value, and then the people can use it. And later, this expansion led to another side use case, which is the decentralized websites. So if you ever heard about decentralized storages, when you upload your content, the systems gives you some hash, which called content hash, to retrieve those uploaded the content, basically. And we realized that if we keep this content hash under ENS, then if we can somehow provide additional feature to the traditional browsers, like resolving ENS names, you can actually have a decentralized websites. Basically, you are just uploading your website files into the decentralized storages and then putting the content hash under the ENS. And if a browser provides a resolution for the ENS, like Brave or Opera browsers, or if you have an extension to do that, like MetaMask, then when you write the ENS name into your browser, you are retrieving your decentralized website. So basically, name everything. So CCIP read, or Cross-Chain Interoperability Protocol read, secure data retrieval. So the CCIP read is crafted by Nick Jensen, the founder of the ENS, as an EIP, or here EIP. So basically, this is a standard way of how to retrieve the information from off-chain to on-chain, so we don't have to do things on-chain, or we don't have to store things on-chain, which eliminates many things. And of course, the gas cost. And like before deep diving into the technical aspects of it, I want to tell why we needed that, because like there are many technologies out there. Why we didn't just look at them. So the problem was, we were just thinking like, how can we store ENS data on L2 without clients having to know how to query every L2, without any additional trust assumptions? Actually, let me first explain a little bit more about the first one. So without clients having to know how to query every L2, which means that we have a lot of libraries like Ethers.js and Web3.js and this kind of libraries. And when we want to query the blockchain, or the Ethereum in this case, or the L2s, then if we don't have any proper specification, we have to just give all the specifications beforehand doing any, I don't know, like transaction or querying. So we were trying to eliminate that. So this was our first problem. So we didn't want any developer to, add any extra effort to the developers doing that. And the second problem was without any additional trust assumptions. So we want to create such a specification that we don't want to add any additional trust assumption on, I don't know, like on L2s or onto the client or any different implementations. So this was our second problem. And the third problem, without any L1 commits on update. So we should create such a specification that when you do something on ENS, you shouldn't update the L1, so it won't cost you anything. So it will be gas-free. And this was the third problem. And another one, without any transactions on query. So it's the same. So we don't want any transaction cost in any level. So we have to also dig into that. And without hard requirements on the L2 capabilities, so if we are implementing something with the CCIP read specification, we don't want to modify any L2. So we should be able to just do something without touching them. And we came up with this. So this is the CCIP read, and I will just briefly explain what it does and how it works. Basically, we have one client. As I explained, this can be a test.js, web3.js, whatever you call. And we have a contract. It's just like basically a contract in L1 that's going to integrate the CCIP read protocol into it. And also the client will basically interact with. And this is the third component which the CCIP read introduced, which is called gateway. So the client asks something to contract. Let's say it's just some function. And then contracts in the regular traditional blockchain world, if this function, if this query doesn't have any result, the contract should just say, oh, I don't have this information, and just raise an error. But in this case, instead of just a regular error, it reverts a custom error, which called off-chain data lookup. So this specific custom error helps us to run our own CCIP read specification. And this information has the sender information, the gateway URL, and some call data, and the callback function, which I will explain a little bit later, and then extra data. And then this revert when we get this revert back, the client doesn't raise an error to us. Instead, it handles it automatically because we already contributed all these clients and make a implementation for the CCIP read support. So the client gets these informations, and then using the URL from the custom error, going to the gateway URL and asking the same thing to the gateway and say, for example, hey, we tried to call this sum function, we tried to get the information, but we couldn't find it. And it told that, instead of reverting error, it told that, oh, this information is actually in the gateway. Or actually gateway knows about it. And then gateway checks the URL and the call data and everything. And then if there is some result, it returns the result to the client again. But this result is opaque, so it's not transparent. Means that still the client cannot understand this result, and it returns the response to the callback function, to the contract back. And the contract, after getting this result, the contract resolves that response back to you from the contract. So you just doing an interaction between client and contract and the gateway URL, just like how you are interacting with L1 from the outside. And at the end, you get the result, but we didn't write anything to contract, so we didn't change any state. So all what we did is we called the contract told us where it is, and the gateway just provide this information to us. I know this was not that easy, so I will go step by step with the use case, with some use case from ENS. So this is you. And assume you want to resolve some ENS name. Let's say Tarikulu.ETHMilan.ETH. And then in the regular contract, when you actually, yeah, this is for DAPCon. Sorry, let's say DAPCon. Okay. So, and in the regular world, the contract should tell you that, no, I don't have this information. Like, I don't have Tarikulu.dapcon.eth in my record. And that's it. But we see with CCIP read, it says that I don't have this information. but I know where it is. And I'm just sending you all the information necessary that, so you can find the information, real information. And then the client calls the gateway, and gateway, based on how you implemented the CCIP read gateway, it can be off-chain, it can be on-chain. It just goes to the actual source of the information, retrieves the information back with the proof, and then calling the same contract but different method from the contract with the information it gathers from the client, from the gateway, and then the contract checks if the proof is correct. It just de-encrypt the result to you, and then at the end of all this flow, you get the address basically. And again, you didn't get the information from contract, you get the information from contract indirectly without changing any state. So CCI, when I was telling about the flow, I told that there are two types of implementations, one off-chain interaction and the one on-chain interaction. So the CCIP read gateway can be can have an infrastructure either for off-chain. So basically what that means, you can run your own gateway and you can keep all the information in a simple database. So you don't have to use the L2, you don't have to use any blockchain technology there. And when the user query the blockchain, at the end the gateway will just check your database and will see if there's an information, and it will provide the information to user. So there are advantages of it and there are disadvantages of it. And in off-chain interaction, so it may require an additional verification. Means that based on your use case, you should figure out what kind of verification you're going to do. So it can be, for example, the off-chain gateway can keep a key pair, like the private key of some, let's say, generated address, trusted address. And then in the contract, you can do the verification of this address. Basically, if any information sent from the gateway signed by this key pair that you provided to your off-chain gateways, basically. And in on-chain, before on-chain, let's go to other things. And so another problem is, its first thing is it may need a trusted signer, and the data may not be available publicly because based on the, let's say, project may just keep the database private, and you may not be able to see what is inside of that database. But at the same time, they cannot alter that too because it's going to be signed. So it is still not really trustless, but we are decreasing the trust vector here. So increasing, yeah. No, decreasing. So, and in on-chain interaction, the verification is much more straightforward. You basically do a miracle proof verification, and the thing is, the disadvantages is it's not free like off-chain one, because then you are using another L2 and the transaction must be done for writing. The transaction must be done on L2 level, but it's going to be like super cheap relatively to L1. And so this one. All right, sure. Just quickly, of course I won't go on this anyway. This is just a Vitalik's take of how we can use the CCIP read to scale the ENS. So it's more or less like what I explained in the CCIP read. Basically, it's just a couple of interactions, and the user just asks the record, and then it goes to the gateway. Gateway asks L2, get the miracle proof, do the proof in the contract level, and then says that yes, you have ENS in L2. Okay, so I think I'm out of time. I would love to tell more if you are interested. So yeah, it's an intense topic. I try to cover them all, but when I tell everything about ENS and the CCIP read at the same time, 20 minutes is nothing. Thank you.
No worries, and thank you very much.